Friction is important. Friction is necessary. Friction is essential. In fact, friction is a necessary evil. ये एक ज़रूरी बुराई है जिसे हम फ्रिक्शन कहते हैं. But still the friction is one of the most important forces, because we cannot do most of our daily life work without friction, without the help of friction. For example, I cannot hold this chalk in my hands without friction. We cannot hold many things in our hands. We cannot do many things without friction. We cannot walk without frictions. Vehicles cannot run without frictions. So friction is important. That's why in today's lectures I am going to deal with friction. Actually, in this lecture we will deal with some applications of friction. The whole understanding of friction will be discussed in a separate lecture. Okay. Well, students, friction is included in class 11th NCERT class 11 chapter 5 in laws of motion. Okay. So this is going to be the lecture first on this topic, and we will discuss friction itself, the force of friction and its properties itself in separate lectures. Okay. So here we are going to discuss some specific applications, in fact a specific problem which you are seeing on the blackboard, the block on block problem. So in today's lecture I am keeping the promise which I made to my students that I will deliver a lecture, a very comprehensive and detailed lecture on block problem. Okay. So in this lecture this problem will be discussed in a very systematic manner. Okay. So here are two blocks M1 and M2 which are kept on a surface which may be rough. There may be cases the surface is rough or surface is perfectly smooth, or the surface between the two blocks is smooth or it is rough. So all these cases will be discussed in a very systematic manner. Though this lecture is going to be a very informative and very useful for students who are preparing for their NEET and JEE mains and as well as JEE advanced examinations. Also this is very important for students for their regular examinations. Okay. So here in the very first case which I am going to discuss, the case 1, let's start. Case first, when two blocks are one block on top of the other and they are placed on a smooth surface. So friction coefficient between ground and block M1 is 0, and also the friction coefficient on these two blocks is also 0. The zero friction between any two surfaces in contact, it sounds very interesting, but there is no such thing. Whenever two surfaces are in contact, no matter how much smooth they are, there is always some friction force. Okay. So concept of zero friction between two surfaces in contact is just an ideal one. In reality or in practice, it doesn't exist. So this will be later in the lecture when I will deal with friction, only friction, Okay. So here let us assume that the friction coefficient between ground and lower block and between the two blocks is 0. Okay. And also there is a condition first. As a condition first, let us consider that a horizontal force F is being applied. A horizontal force F is being applied on the lower block M1. Okay. So since there is no friction between ground and block M1, the block M1 will slide under this force. Okay, it will move forward और ये बहुत ही स्मूथली इस ग्राउंड पर से निकल जाएगा विदाउट एनी मोशन स्टार्टेड इन ब्लॉक M2. M2 ब्लॉक अपनी जगह से हिलेगा भी नहीं ड्यू टू इट्स इनर्शिया ऑफ रेस्ट, और ये इसके नीचे से स्मूथली निकल जाएगा. ओके, ब्लॉक M1 इसके नीचे से स्मूथली निकल जाएगा विदाउट कॉजिंग एनी मोशन इन ब्लॉक M2, और इसके नीचे से जब ये निकल जाएगा देन ब्लॉक M2 विल फॉल डाउन राइट ओवर इट्स इनिशियल पोजीशन ऑन द ग्राउंड. ब्लॉक M2 जो है वो अपनी जगह पे ही रहते हुए ब्लॉक M1 इसके नीचे से निकल जाएगा विद एक्सेलरेटेड मोशन. ओके, एंड ब्लॉक M2 अपने इनर्शिया की वजह से अपनी जगह पे ही बना रहेगा एंड इवेंचुअली इट विल फॉल डाउन ओवर इट्स इनिशियल पोजीशंस ऑन दिस ग्राउंड. ओके, सो द एक्सेलरेशन इन दिस केस of block M1 will be given by A equal to F upon M1. This is the condition first, and the force F is applied on block M1. In fact, there is no such thing as maximum force or minimum force in this condition. In this situation, there is no such thing as, it doesn't depend upon the amount of force F. It can be any amount of force. Okay, so in this condition force can be plus infinity to the negative infinity. It can have any value between plus infinity to negative infinity. So this was the first condition, and this force F is applied on block M1. In the second condition, the same force is applied on the upper block M2. So the same force F is being applied on upper block M2. So this is the condition second. When force is applied on block M2, so इस कंडीशन में block M1 will stay at its initial position because of its inertia of rest, और block M2 इसके ऊपर से smoothly निकल जाएगा and eventually it will fall down in front of block M1. Okay, and eventually it will fall down. जब इसकी बाउंड्री ख़त्म हो जाएगी, ये इसके एजेस पे पहुँच जाएगा, तो it will fall down on ground. And what will be the acceleration of M2? So in this condition, acceleration of M2 will be given very easily. A equals F upon M2. Okay, again there is no such restrictions what is the maximum value of F or minimum value of F. Okay, so this force can take any value between plus infinity to negative infinity. Okay. Here both surfaces are smooth. In the first case, the friction coefficient between both the surfaces is 0. Okay. Now let's assume the second case. In case second, the ground is rough. Okay, so the coefficient of friction between ground and block M1 is not 0, but between M1 and M2 the coefficient of friction is 0. Again, as a condition 1, the condition 1 case second is mu1 is not equal to 0 at mu2 is equal to 0, and as a condition first, the force F is being applied. The force F is being applied on block M1. Okay, the force F is being applied on the lower block. Okay, so force of friction acting on block M1 in opposite direction is suppose F1. So what is the net force on block M1, which is given by F1 equal to F minus small f1. Okay. So in this condition, the block M2 will not move, only the block M1 will move with an acceleration a. Okay. So acceleration of block M1 will be given by A equals net force of M1 divided by M1 equal to F minus small f1 divided by M1 . One thing is to be noticed here, that as long as the block M2 sits over block M1, okay, ये बहुत ही वेरी शॉर्ट इंटरवल ऑफ टाइम के लिए इसके ऊपर रहेगा, जब तक कि इसके नीचे से ये ब्लॉक M1 निकल नहीं जाता है, उस ड्यूरेशन के लिए ब्लॉक M2 इसके ऊपर रहेगा। सो यहाँ पर जो नेट नॉर्मल रिएक्शन है, दैट विल बी गिवन बाय, जब तक ये इसके ऊपर बैठा हुआ है उस वक्त के लिए नॉर्मल रिएक्शन will be given by R equal to, दोनों ब्लॉक्स का मास इसके अंदर इंक्लूड होगा, μ1 m1 प्लस m2 इंटू जी। तो उस कंडीशन में एक्सीलरेशन जब तक कि इसके ऊपर ये सिट कर रहा है, A इक्वल्स टू F माइनस म्यू m1 प्लस m2 g अपॉन m1। ओके, जब तक सिट कर रहा है, जब तक एक्सीलरेशन इस रिलेशन से दिया जाएगा, एंड इवेंचुअली द ब्लॉक m2 विल फॉल डाउन बिहाइंड द जस्ट बिहाइंड द ब्लॉक M1। जब ये इसके नीचे से निकल जाएगा तो ब्लॉक M2 अपनी इनिशियल पोजीशन जो उसकी ग्राउंड पर थी उसके ऊपर फॉल डाउन करेगा। तो उस वक्त नॉर्मल रिएक्शन विल चेंज, क्योंकि उस वक्त सिर्फ ब्लॉक M1 का वेट ही वर्क करेगा, नॉर्मल रिएक्शन सिर्फ ब्लॉक M1 के वेट से ही आएगी। सो उस कंडीशन में एक्सीलरेशन will be given by F minus mu m1 g अपॉन m1. ओके, सो इसमें दो तरीके के एक्सीलरेशन हमें देखने को मिलेंगे. पहला एक्सीलरेशन उस टाइम के लिए विच विल बी अ वेरी शॉर्ट इंटरवल ऑफ टाइम, जब तक कि ब्लॉक m2 m1 के ऊपर सिट कर रहा है, इसके ऊपर बैठा हुआ है, जब तक कि ये इसके एजेस एक दूसरे को क्रॉस नहीं कर जाते हैं, तब तक इसका नॉर्मल रिएक्शन m1 प्लस m2 इंटू जी रहेगा. और जब इसके ऊपर से ये फॉल डाउन कर जाएगा तो नॉर्मल रिएक्शन चेंज होके m1 जी रह जाएगी. तो एक्सीलरेशन इस फार्मूले से आएगा. इनफैक्ट हम देख सकते हैं कि ये एक्सेलरेशन जो है वो थोड़ा कम है, जब तक कि इसके ऊपर सेट कर रहा है तो एक्सीलरेशन थोड़ा कम है, और जैसे ही इसके ऊपर से जंप कर जाएगा, पीछे गिर जाएगा, एक्सीलरेशन थोड़ा इंक्रीज कर जाएगा. ओके, आर यू गेटिंग माय पॉइंट? ओके, लेट्स मूव अहेड टू second condition. This was the first condition. And as a second condition, when the same force F is being applied, the same force is being applied on block M2 or upper block, so as a condition second, mu1 not equal to 0 and mu2 equal to 0, and F is being applied on block M2. F is applied to upper block. Okay, so in this condition, since there is no force of friction between M1 and M2, so the block M1 will not move at all. Okay, because there is no friction between these two surfaces, they are smooth. तो ये इसके ऊपर से निकल जाएगा और ब्लॉक M1 अपनी जगह पर ही बना रहेगा. सो इन दिस केस टुगेदर मोशन इज नॉट पॉसिबल. ओनली द ब्लॉक M2 विल मूव विद एन एक्सीलरेटेड मोशन. से द एक्सीलरेशन ऑफ ब्लॉक M2 इज A, which will be given by A equals F upon M2. Okay, now let us move ahead to case third. Now let us assume case third. When the ground is smooth, there is no friction between ground and block M1, but a certain value of friction exists between the two blocks. Okay, so mu1 equal to 0 and mu2 is not equal to 0, it has got some value. So in case third, mu1 equal to 0 and mu2 is non-zero. Okay, again as a condition first, the force F is applied on lower block M1. A horizontal force F is applied on lower block M1. Okay, So since the block M1 and on top the block M2, they all rest in a smooth surface on a smooth ground, so there is a possibility of together motion. Okay, for a certain value of f, there is a possibility of together motion कि दोनों एक साथ साथ चल सकते हैं. लेकिन जैसे ही आगे जाएगा ब्लॉक M1, जैसे आगे जाएगा अपने इनर्शिया की वजह से ब्लॉक M2 यहां रहना चाहेगा, बल्कि ये पीछे छूटेगा, ये पीछे की तरफ को जाएगा और यहां इनके बीच में फ्रिक्शन का फोर्स भी है. सो ब्लॉक M1 जैसे आगे जाएगा ब्लॉक M2 को ये पीछे छोड़ेगा कि ब्लॉक M1 का मोशन इस डायरेक्शन में होगा एंड फ्रिक्शन फोर्स ऑलवेज opposes the relative motion. ब्लॉक M2 की टेंडेंसी पीछे की तरफ जाने को होगी, तो इनके बीच में जो ये फ्रिक्शन का फोर्स है ये आगे की तरफ को लगेगा. सो ब्लॉक M1 पर ये फोर्स आगे की तरफ को लगेगा, फ्रिक्शन का फोर्स. दिस इज फोर्स ऑफ फ्रिक्शन F2 acting on block M2. Again, since the block M1 ये आगे की तरफ को जा रहा है और इन दोनों सरफेसेस के बीच में फ्रिक्शन है, तो ये आगे की तरफ को जाएगा तो फ्रिक्शन इसको पीछे की तरफ को खींचेगा. ब्लॉक M1 आगे की तरफ को जाएगा तो ब्लॉक M1 M2 के बीच का जो फ्रिक्शन फोर्स है वो ब्लॉक M1 को पीछे की तरफ को ड्रैग करेगा. तो इसके ऊपर सेम फ्रिक्शन जो इन दोनों सरफेसेस के बीच है वो ऑपोजिट डायरेक्शन में अप्लाई होगा. So same friction force F2 will apply on block M1 in opposite direction. So this is the first condition. Okay, when the force F is being applied on the lower block M1. So let us deal with the net forces. First we will deal for the motion of block M1, and let us assume that they are moving with a common acceleration. Okay, for the moment we are assuming that both blocks are moving with a common acceleration given by A. तो ये certain value of external force जो हमने लगाया हुआ है इस पे डिपेंड करता है कि ये टुगेदर मोशन होगा, इनका कॉमन एक्सीलरेशन होगा या तो नहीं होगा. ओके, बट फॉर द मोमेंट वी आर assuming that both are moving together. Okay, so net force on block M2 is solely the force of friction जो इसे आगे लेकर के जा रहा है. So for the motion of block M1, for the motion of block M2 of upper block M2, we can write down the equation. The net force F2 is equal to force of friction F2, which is equal to mu2 M2 into G. The common acceleration we have assumed equal to A, which implies that M2 into A equal to mu2 M2 into G. mu2 cancelled out, M2 cancelled out by M2, and the acceleration of block M2 is mu2 into G, which is also the acceleration of the whole system. इन दोनों ब्लॉक्स का कॉमन एक्सेलरेशन हमने ड्यून किया है, तो यही एक्सेलरेशन ऑफ ब्लॉक M1 का भी होगा. ओके, सो फॉर ब्लॉक M1, for block M1, net force F1 equals, for forward motion F must be greater than F2. Okay, when का acceleration forward direction में है, if they are moving forward, then वन थिंग इज प्रेटी सर्टेन, ओके, कि एफ जो है वो इस फोर्स से ज्यादा होना चाहिए. तो नेट फोर्स इज एफ माइनस F2, okay, and since there is a common acceleration, so we can write down by Newton's second law, m1a equal to F minus, and F we have already evaluated, which is mu2 m2 g, mu2 m2 into g, and putting the value of a here, mu2 g, m1 into mu2 g equal F minus mu2 m2 into g. Okay. So from this equation we can easily evaluate the value of force for which there will be a common acceleration. So F will be, this can be taken here, F will be m1 mu2 g plus m2 mu2 g. Okay, so take out mu2 g is common, mu2 g m1 plus m2. So this is the maximum amount of force for which both blocks will move together with a common acceleration. So the maximum amount of force is given by this, and we can recheck this for common acceleration because this is the net force acting on this system of mass m1 and m2. So net acceleration A into net mass m1 plus m2 is equal to mu2 g into m1 plus m2. Okay, so A equal to mu2 g. Okay, which we have already evaluated that net acceleration is it, and net acceleration here is also mu2 g. Okay, so this was the first condition when the force F was applied on lower block M1. As a second condition, the case remains the same. The case remains the same as mu1 equal to 0 and mu2 is non-zero. So let us see what happens when we apply the force on the upper block. And the force is applied on the upper block like this. The force is F is being applied on the upper block. And again, let us assume that both are moving with a common acceleration, or they are moving together. So since there is no friction between ground and block M1, so it is pretty obvious that there exists a force, there exists a maximum force for which both blocks move together one top of the other. बिल्कुल ये स्मूथ है तो बिल्कुल पॉसिबिलिटी है कि अगर यहाँ पर फ्रिक्शन है तो ये फ्रिक्शन इसको आगे की तरफ लेकर के जाएगा. ओके, सो लेट अस assign the direction of forces. Okay, so as a condition second, force F is applied on the upper block M2. So upper block आगे की तरफ को जाने की कोशिश करेगा, फ्रिक्शन का फोर्स ऑपोजिट डायरेक्शन में लगेगा. So यहाँ पे फ्रिक्शन है, since there is friction between M1 and M2, so फ्रिक्शन का फोर्स which is F2 will oppose its motion. It will be opposite in the direction of motion, and common acceleration we have already assumed is A. Now let us think about the forces on block M1 on lower block. So जब ये M2 आगे की तरफ को जाएगा तो ब्लॉक M1 पीछे छूट रहा होगा. इधर ब्लॉक M1 की टेंडेंसी क्या होगी, इसको पीछे छोड़ने की होगी. ब्लॉक M2 आगे जा रहा है, ब्लॉक M2 उसको पीछे जाता हुआ दिखेगा. तो उस कंडीशन में फ्रिक्शन का फोर्स ब्लॉक M1 पर आगे की तरफ को लगेगा. तो ये फ्रिक्शन ही है इनके बीच में जो ब्लॉक M1 को फॉरवर्ड डायरेक्शन में मूव कराने की कोशिश करेगा. सो द ओनली फोर्स व्हिच इज एक्टिंग ऑन द लोअर ब्लॉक M1 is also the friction between M1 and M2. So if this is F2, then the force on block M1 is also F2 in the forward direction. So let us evaluate let us analyze the motion of lower block M1. Okay, so for lower block M1 there is only force F2 which is acting on it, and common acceleration is A. Then net force F1 equal to F2, and from Newton's second law M1 into A is common acceleration, is F2 is mu2 M2 into G. Okay, where M2 G is normal reaction of the block M2 and mu2 is coefficient of friction, which is a very common formula. Okay, so A will be given by A equal to common acceleration mu2 M2 upon M1 into G. So this expression gives the common acceleration of both blocks M1 and M2. Now for the motion of block upper block, for the motion of upper block M2, for block M2 the net force is F2 equal to, this in forward direction and this is reverse directions. F must be greater than F2 for forward motion. So the net force will be the difference of F and F2. So F minus F2 is the net force on block M2. So since there is a common acceleration, so M2A from Newton's second law, F minus F2 which is mu2 M2 into G, putting value of A here, M2 into mu2 M2 upon M1 into G equals F minus mu2 M2 G. Okay, so we can evaluate the value of maximum force F equal to M2 into mu2 M2 upon M1 into G plus mu2 M2G. Here mu2 M2G is common here, so we can take it out. So F equal to mu2 M2G mu2 m2 g bracket here only there will be m2 upon m1 plus 1, m2 upon m1 plus 1, or we can also rewrite this as the maximum force for which the both the block move together with the common acceleration is given by mu2 m2 upon m1 into m1 plus m2. Okay, so this expression gives the maximum forward force in horizontal direction, okay, for which both blocks will move together with a common acceleration. So this was the case third and condition second. Now we will move forward. The lecture is going to be a little bit lengthy because at the very end of this lecture we will solve some problem based upon this analysis. Okay, तो कुछ बहुत ही इंटरेस्टिंग सी प्रॉब्लम करेंगे to evaluate and to check our formulation. तो थोड़ा पेशेंस रखिएगा. So as the case fourth, which is the most important one. Okay, the case fourth is going to be the most important and most interesting one. You will really enjoy it. When the ground is rough, so mu1 is non-zero and there is a friction between the two blocks also. So mu2 is also non-zero. Okay, so this is the case fourth, when mu1 is non-zero, has got some value. Mu2 is non-zero, it also got some value. So both the surfaces are rough. Okay, so ground and m1. Okay, so ground and m1 are rough, and m2 and m1 there is also roughness. Okay, and again as a condition first, as a first condition, the force F, the horizontal force F applied on lower block M1. So as a condition first, when the horizontal force F is applied on the lower block M1, यहाँ पर है, जहाँ मजा आने वाला है बहुत ज़्यादा. Okay, and the concept is going to be very clear, just like a plain glass. Okay, so let us analyze the various forces acting on the two blocks. जब ये आगे की तरफ को जाएगा तो ये पीछे छूट रहा होगा, तो इस पर फ्रिक्शन का फोर्स आगे की तरफ को लगेगा, like this. तो ब्लॉक M2 पर फ्रिक्शन का फोर्स which is F2 आगे की तरफ को लगेगा, और ये ब्लॉक आगे जा रहा होगा, इनके बीच में रिलेटिव मोशन है, तो फ्रिक्शन का फोर्स इस ब्लॉक को अपोज करेगा पीछे की तरफ, like this, same force F2. Again, since the ground is also rough, okay, now in this case the ground is also rough, so ground और M1 के बीच में भी एक फोर्स एक्ट करेगा जो कि इस फॉरवर्ड मोशन को अपोज करेगा, which is force F1. Okay, So now let us examine the various forces on the two blocks. First, on block F2 there is only force of friction. जो इसे फॉरवर्ड डायरेक्शन में लेके जा रहा है, which is only the force of friction. Okay. So for block M2, थोड़ा छोटा लिखा हुआ हो सकता है. Okay. So when you are watching this video, you can zoom in अपने वीडियो एडिटर में या यूट्यूब में ही आप इसे जूम कर थोड़ा देख सकते हैं. ठीक. तो और ज़्यादा बड़ा लिखेंगे तो इस पे स्पेस थोड़ा नहीं बचेगा. सो प्लीज डू मी दिस फेवर. सो फॉर द मोशन ऑफ ब्लॉक M2 there is only one force which is due to friction between block M1 and M2. So net force on block M2 is equal to F2, which is force of friction. So from Newton's second law, the common acceleration is assumed here A. Okay, we are assuming that both blocks are moving with a common acceleration. अब ये बाद में एनालाइज करके हमें फर्दर एनालाइज करके पता चलेगा कि ये चल सकते हैं या नहीं चल सकते. This depends upon the values of these coefficients of friction between ground and between two blocks, and also upon the value of this force. Okay. So M2A is equal to mu2 M2G. So A equal to mu2G. Okay. Now for the motion of block M1, this is the common acceleration. Okay. Now for the motion of block M1, two forces F1 and F2 are acting in opposite direction, and the external force F is acting in the forward direction. So for the system to move in the forward direction, F must be greater than these two forces F2 and F1. Okay, so the sum of F2 and F1 should be smaller as compared to force F. So net force on block M1, which is F1, which is equal to F minus sum of F1 and F2. Here we have already evaluated value of F2, which is equal to mu2 M2G. For value of F1, is the net normal reaction in case of M1 is M1 plus M2 into G. Why? Because the block M2 is sitting on block M1, so it is also exerting its weight and adding to its original normal reaction. Okay. So F1 equal to mu1 equal to M1 plus M2 into G. So again, net force on block M1, which is F minus F1 plus, we put the value of F1 and F2. F1 is mu1 M1 plus M2 into G plus mu2 M2G. Okay, So if the common acceleration is a, which we have already assumed, then from Newton's second law, m1 into a is equal to f minus mu1 m1 plus m2 into g plus mu2 m2 into g. Now putting the value of a from this equation, which is mu to g, so m1 mu to g equals f minus mu1 m1 plus m2 into g plus mu2 m2 into g. So value of maximum force F maximum, which can be applied for together motion, is given by, we can take this on this side, m1 mu to g plus mu1 m1 plus m2 into g plus mu2 m2 into g. Okay, so if you have copied this, I am erasing this, okay, because the space has finished. So here the maximum force, we can solve this, we can make factors of this. We can rearrange these terms and simplify this. So F maximum is equal to, so here in these terms mu2 and g is common. Okay, so here mu2 and g are common in these two terms, so we can take this out. So mu to g m1 plus m2 plus mu1g m1 plus m2. Okay, now m1 plus m2, this term is common, so we can take it out. So what is remaining as mu1 is g mu1 plus mu2 to m1 plus m2. Okay, this is a very simple and very important result. Okay, so F maximum in this case, is given by, and the force is applied on lower block, and both surfaces are non-friction surfaces. यहाँ पर both surfaces have friction, तो इस केस में कुछ भी करने की जरूरत नहीं है, कुछ और बात सिर्फ क्या करना है इस केस में, when there is friction between both surfaces or force is being applied on the lower block, so what is the maximum force? एनालाइज करना जानते हैं, बहुत अच्छी बात है, ठीक। लेकिन अगर टाइम बहुत ही ज्यादा कम है, और जो कि होता है, तो उसमें किसी भी फचड़े में पड़ने की जरूरत नहीं है। जस्ट यूज दिस इक्वेशन टू इवैल्यूएट मैक्सिमम फोर्स विच इज रिक्वायर्ड फॉर टुगेदर मोशन। ये इक्वेशन, दिस इज अ वेरी ब्यूटीफुल इक्वेशन, ओके। इसी के लिए सारी मेहनत की गई है और आगे भी आने वाली है, और एक इससे अच्छी, बहुत खूबसूरत, बहुत ब्यूटीफुल इक्वेशन आगे भी आने वाली है। तो क्या करना है, यू जस्ट ऐड द टोटल कोएफिशिएंट ऑफ फ्रिक्शन मल्टीप्लाइड बाय टोटल मास इनटू जी, ओके। सो इन सच केस मैक्सिमम फोर्स F maximum is equal to total coefficient of friction, total coefficient of friction into total mass of the system into G. ओके, तो सिर्फ ये इक्वेशन यूज करेंगे ऐसे केस में, और हमें वो मैक्सिमम फोर्स की वैल्यू बहुत इजीली कैलकुलेट हो जाएगी जस्ट इन वन स्टेप. ओके, एक ही स्टेप में मैक्सिमम फोर्स जिसके लिए टुगेदर मोशन पॉसिबल होगा इस इक्वेशन से आ जाएगा. तो नोट इट डाउन, तो पॉज करके भी आप नोट कर सकते हैं. So now this was the condition first when the force was being applied on the lower block M1. Now move to the condition second of case 4. Condition second of case 4. And the force F is being applied on the upper block. और यहीं पर है सारा गेम, यहीं पर है सारा गेम. अब क्या होने वाला है? केस 4 इज दोनों सरफेसेस में फ्रिक्शन है, नॉन जीरो फ्रिक्शन कोएफिशिएंट है दोनों सरफेसेस के बीच में, ग्राउंड M1 के बीच में भी और M1 M2 के बीच में भी. As a condition second, the force, the horizontal force is being applied on the upper block, the block M2. Okay. The force F is being applied on the upper block M2. So let us analyze the net forces on the two blocks. M2 आगे की तरफ जाएगा, इनके बीच का फ्रिक्शन पीछे की तरफ को ड्रैग करेगा, तो F2 पीछे की तरफ रहेगा. ओके, M2 पीछे की तरफ को जाएगा, M2 आगे की तरफ हो जाएगा, ब्लॉक M1 पीछे की तरफ को छूट रहा होगा, तो ये इसे अपने साथ लेकर चलने की कोशिश करेगा. तो सेम फोर्स यही वाला इसको आगे की तरफ को ड्रैग करेगा. F2 आगे की तरफ रहेगा M1 पर, बट देयर इज आल्सो फ्रिक्शन बिटवीन ग्राउंड एंड M1, तो ये आगे की तरफ हो जाएगा. तो ग्राउंड और M1 के बीच वाला फ्रिक्शन विच इज F1 उसे पीछे की तरफ को ड्रैग करेगा. ओके, so now let us analyze the various forces on the two blocks. Next for block M1, net force F1 will be equal to F2 minus F1. For together motion, for forward motion, F2 must be greater than F1. Okay. So this equation is going to be very, very critical. Here F1, which is the net friction force on M1, will be given by mu1 M1 plus M2 into G, because M2 is sitting on block M1, so its weight is also adding to the normal reaction of mass M1. So F1 is given by this, and F2 is mu2 M2 into G. Okay, this is very clear and very, very simple. Now for the motion of So if the common acceleration is a, then m1 into a will be f2 minus f1 mu 2 m2 g minus mu1 m1 plus m2 into g. So common acceleration A is given by mu 2. G can be taken out as common, mu 2 m2 minus mu1 m1 plus m2 upon m1 into g. So this is the common acceleration of the system. Okay. Now for the motion of block M2. For the motion of block M2, the net force on block M2 for forward motion, for together motion F2 is equal to F minus small f2. The common acceleration is assumed as A, so m2 into A from Newton's second law, F minus, and F2 is mu 2 m2 g. Which implies that F is equal to m2a plus mu 2 m2 g. So putting the value of a from this expression, mu 2 m2 minus mu 1 m1 plus m2 upon m1 into g plus mu 2 m2 into g. Now g is common both terms, so we can take it out. तो अगर आपने ये कॉपी कर लिया है, इसको आप देख लीजिएगा. इस इक्वेशन को मैं इरेज कर रहा हूँ बिकॉज आई एम रनिंग शॉर्ट ऑफ स्पेस. स्पेस और टाइम ही तो है, तो कुछ है. स्पेस एंड टाइम, space and time. I have created space, okay, but we cannot create time. So the maximum force F for together motion is given by G कॉमन ले लीजिए और M को उधर मल्टीप्लाई कर लें एलसीएम लेकर के M1, तो इसमें बचता है mu 2 m2 प्लस mu 2 m1 g, mu 2 m1 प्लस माइनस ये वाला टर्म बचेगा, इस टर्म mu1 m1 प्लस m2. So g upon m1, solve this bracket. Here mu 2 is common, take it out. Mu 2 m1 plus m2 minus mu 1 m1 plus m2. कुछ बढ़िया होने जा रहा है. g upon m1 plus m2 is common, so m1 plus m2 into mu2 minus mu1. This is the maximum force which can be applied on the upper block for together motion, if it is possible. Okay, remember. हो भी सकता है, नहीं भी हो सकता. It depends upon the values of mu2 and mu1 and also upon the masses. Okay. तो यहाँ पर ये बात हो गई है. The maximum force F maximum is given by this. So this is also a very beautiful equation. इसमें कुछ करने की जरूरत नहीं है. अपर ब्लॉक पे अगर फोर्स लगा हुआ है तो मैक्सिमम फोर्स निकालने के लिए यूज दिस इक्वेशन. तो इस इक्वेशन का यूज कीजिए. वेरी वेरी सिंपल. ओके, सम ऑफ द टू मासेस डिवाइडेड बाय लोअर मास जिस पर फोर्स लगा हुआ नहीं है, अपर पे लगा हुआ है, एंड मल्टीप्लाइड विद द डिफरेंस ऑफ कोएफिशिएंट्स ऑफ फ्रिक्शन between two surfaces. Okay, between ground and between the two blocks. Now if we carefully analyze this expression, then it turns out that for forward motion it is essential that value of mu2 must be greater than value of mu1. टुगेदर मोशन के लिए पहली नेसेसरी कंडीशन, द फर्स्ट नेसेसरी कंडीशन इज दैट mu2 must be greater than mu1. Okay, so I am erasing this. All this stuff I am creating this space. So for together motion, the necessary condition is that mu2 must be greater than mu1. Okay, so if mu2 is greater than mu1, there may be, it is not necessary, there may be together motion. Okay, if mu2 is greater than mu1, so chances हैं कि दोनों blocks together move कर सकें. Okay, और अगर वो कर पा रहे हैं तो फिर ये इक्वेशन इजीली काम करती है और बिल्कुल करेगी. ओके, देन देयर मे बी टुगेदर मोशन. So mu2 is greater than mu1 is the necessary condition for together motion. This is necessary condition but not sufficient. This is necessary condition. mu2 must be greater than mu1 for together motion is the first necessary condition, but this is not the sufficient condition. It doesn't give the total information either there may be a together motion or not. So we have to move ahead. We have to analyze further. We have to evaluate the sufficient condition. Necessary plus sufficient condition. अगर ऐसी कुछ मिल जाए तो फिर प्रॉब्लम हमारे लिए बाएं हाथ का नहीं बल्कि चुटकियों का खेल हो जाएगी. ओके, और बिल्कुल होने वाली है, आई प्रॉमिस. सो secondly, if mu2 equal equal to mu1, then maximum force F maximum is equal to 0. What does it mean? This is very beautiful result. अगर इन दोनों सरफेसेस के बीच यहाँ का फ्रिक्शन और यहाँ का फ्रिक्शन इक्वल है तब मैक्सिमम फोर्स की वैल्यू 0 आती है. What does it mean? It means that if mu1 and mu2 are equal, then there exists no such force. No such force exists in such condition for which together motion is possible. If mu1 and mu2 are equal, then no such force, no any force exists, no matter how much small it is. कोई फोर्स एग्जिस्ट ही नहीं करता है. F maximum is equal to 0. F maximum is equal to 0. Okay. If mu1 is equal to mu2, then F maximum is equal to 0. It means no such force exists for which block M1 and M2 can move together. Okay. Now, as I have already said that mu2 is greater than mu1 is the necessary condition, but this is not sufficient. So, what is the sufficient condition? Let us try to evaluate it. Okay. So, the sufficient condition will be decoded from this equation. For forward motion of block M1, in this case block M2 is moving in forward direction, and if block M1 is also moving along with the block M2, then F2 minus F1 must be greater than 0. Okay. इन दोनों का डिफरेंस 0 से ज्यादा होना चाहिए, तभी ये दोनों साथ चलेंगे. So we have already evaluated F2, which is equal to mu2 M2G, and F1, which is mu1 M1 plus M2 into G, must be greater than 0, imply that mu2 M2 must be greater than mu1 M1 plus M2. Sufficient condition. Okay. So mu2 upon mu1 must be greater than M1 plus M2 divided by M2. Okay. यही वो रिजल्ट. दिस इज द रिजल्ट जिसके लिए इतना सब कुछ किया गया है. दिस इज द सफिशिएंट कंडीशन. mu2 greater than mu1 is the necessary condition. Okay, but the sufficient condition for both block to move together, what we have to check? We have to go for it. We have to check for this. We have to check the masses. We have to check the coefficients of friction, the ratio of mu2 and v1, and the ratio of m1 plus m2 and m2. If this condition is satisfied, then there exists a maximum force for which the blocks can move together. Okay? तो कुछ नहीं करना है, हमें नेसेसरी कंडीशन और ये सफिशिएंट कंडीशन को सबसे पहले चेक करना है. In such problems, what we have to check? We have to check whether the together motion is possible or not. उसके लिए बहुत ज़्यादा कुछ दिमाग लगाने की ज़रूरत नहीं है, उसमें कंफ्यूजन पैदा हो जाता है, दिमाग लगा दिया गया है. ओके. और उसमें अब आप समझ भी गए होंगे बहुत, इसमें इतना अच्छा एनालाइज हो गया है चीज़ों का कि आपको इसकी पूरी समझ भी आ चुकी है. So in such condition, the necessary condition for together motion or necessary and sufficient condition for together motion or mu2 is greater than mu1, and ratio of mu2 and mu1 must be greater than this ratio. एक छोटा सा ब्रेक लेते हैं. So welcome back students, my name is Dr. Ali and you are watching Stargate Educational Research, Ting Tong. Okay, so break से पहले we have discussed about the necessary and sufficient condition for two blocks to move together with a common acceleration in this particular case, which is the most untouched case. ज़्यादातर जगह पे इस केस को बहुत डिटेल में डिस्कस नहीं किया गया है. सो जैसा कि मैंने आपसे कहा था कि हम इस फार्मूलेशन के बाद में कुछ इंटरेस्टिंग सी प्रॉब्लम्स डिस्कस करेंगे. So now it's time to solve some problems. So for this purpose I am erasing this stuff. Okay, बहुत मेहनत से बनाया था, बहुत दुख हो रहा है इरेज करते हुए. इट वैनिश्ड. ओके, सो इसी से रिलेटेड पहला एग्जाम्पल हम ले रहे हैं. देयर आर टू ब्लॉक्स. There are two blocks of mass. This is M1, lower block is M1, which is 5 kg, and M2, which is 4 kg, and the coefficient of friction here is mu1 is 0 and mu2 is equal to 0.5. And the force, horizontal force F, is applied on the lower block M1, and suppose they are moving with a common acceleration A. So first question is, what is the maximum force for together motion? F maximum for टुगेदर मोशन क्या होगा? सेकेंड, एफ की किस वैल्यू के लिए स्लाइडिंग स्टार्ट हो जाएगी बिटवीन 5 किलोग्राम एंड 4 किलोग्राम? फॉर व्हाट वैल्यू ऑफ एफ द 4 किलोग्राम ब्लॉक विल स्लाइड ओवर द 5 किलोग्राम ब्लॉक. सो for what value of F sliding will start? Between M1 and M2. Okay. So let's try to solve it on the basis of our formulation. Here mu1 equals 0, mu2 equal to 0.5. So first of all we have to check whether the together motion is possible or not. So we will apply here the necessary and sufficient condition. So the necessary condition is mu2 upon mu1. mu2 should be greater than mu1, which is satisfied because 0.5 is greater than 0. So first condition is satisfied. Still we are not 100% confirmed whether together motion is possible, so we will go for the sufficient condition, which is mu2 upon mu1 must be greater than m1 plus m2 divided by m1. Okay. So let's check it out. Mu2 upon mu1 0.5 divided by 0. M1 is 5 plus 4 divided by 5. So this is infinity, which is always greater than, this is 9 upon 5. So both conditions are satisfied. So together motion is possible. Okay. So both conditions are satisfied. So together motion is possible. This is 100% confirmed. What is the maximum value of force for which both blocks can move together? What is the maximum value of force for which both blocks move together? So first question is, what is the maximum value of force for together motion? So in this case we know that F maximum is equal to G m1 plus m2, कुछ करने की ज़रूरत नहीं है, mu1 plus mu2. Take value of G equal to 10, okay, into 4 plus 5 into 0 plus 0.5, which is 10 into 9 into 0.5 equal to 45 Newton. So maximum value of force for which the block will move together is equal to 45 Newton. इससे कम होगा तब भी टुगेदर मोशन होगा. So this force must be less than or equal to 45 Newton. Okay. So लोअर ब्लॉक पे हॉरिजॉन्टल फोर्स F लगाएंगे, उसकी वैल्यू 45 मैक्सिमम या उससे नीचे रहनी चाहिए फॉर टुगेदर मोशन. इससे ज़्यादा होगा स्लाइडिंग स्टार्ट हो जाएगी. ओके. फॉर व्हाट वैल्यू ऑफ F स्लाइडिंग विल स्टार्ट बिटवीन m1 एंड m2. सो आंसर ऑफ सेकेंड क्वेश्चन is readily available in this question. If for F any value of F greater than 45 Newton, sliding will start between m1 and m2. Okay, got my point? Very easily, very simply. Okay, so this was the first example. The second example, space, empty space. Empty space is not empty. Okay, empty space is not empty. अभी भी बहुत कुछ है. empty space empty नहीं होता है. यहाँ पे एम्प्टी कर लिया है. नाउ in the second example, same masses, same friction, mu1 equal 0, mu2 equal 0.5, and now the force is applied on the upper block. Okay, So question is, is there is any value of f for which together motion is possible? Is there any value of f for which together motion is possible? Motion is possible. Okay, first question. Second part of the question is f maximum for together motion. And common acceleration. If they move together with the common acceleration, then what it is? कितना है? बहुत गड़बड़ हो गई वीडियो के बीच में। माइक का जैक लगाना भूल गया मोबाइल में। साउंड क्वालिटी में डिफरेंस आएगा थोड़ा सा, प्लीज़ उसको एडजस्ट करिएगा। बहुत ज़्यादा बुरी भी नहीं है, नाइट में बना रहा हूँ। ओके, सो in first part of the question, is there any value of f for which both blocks move together or together motion is possible? So what we have to check? We have to check the necessary and sufficient condition for together motion, which is very easy. And acceleration a, common acceleration क्या होगा सिस्टम का, AC. So solve it. First part, here mu2 is greater than mu1, obviously 0.5 is greater than 0, so necessary condition is satisfied. So we will go for sufficient condition. mu2 upon mu1 should be greater than m1 plus m2 divided by m1, sorry m2. Okay, so mu2 upon mu1, which is 0.5 divided by 0, which is way greater than, this is infinity actually, 4 plus 5 divided by 5, so this is infinity, which is obviously equal to any number. So both conditions being satisfied, together motion is confirmed. Okay, both conditions are testified or satisfied or fulfilled, together motion is possible. Okay, so first part is okay. So what is the maximum force for together motion? कोई भी फोर्स की डायरेक्शन लगाई नहीं है मैंने इसमें, कौन सा किधर को जाएगा, कौन धर जाएगा, फ्रिक्शन का फोर्स किधर रहेगा, कुछ भी कोई कंफ्यूजन होना ही नहीं है. सो एफ मैक्सिमम इन सच केस is equal to is given by the relation m2 upon m1 into g m1 plus m2 into mu2 minus mu1. न यहाँ पर डायरेक्शन दिखाई है फ्रिक्शन की, न यहाँ दिखानी पड़ी है, कुछ नहीं करना पड़ा, जस्ट यूज दिस रेसिपी. वेरी टेस्टी, वेरी यम्मी रेसिपी of the chapter of friction. Okay, so just put these values. This is just like having a soft drink. 5, 4 upon 5. This is M2 is actually 4. 4 upon 5 into 10 into 4 plus 5 into 0.5 minus 0. 4 into 2 into 9 into 0.5. 2 into 2 into 9 equal to 36 Newton. So this is the maximum force F applied on the upper block M2, 36 Newton, for which both blocks will move together, and they will move together was initially testified. Okay. Now the common acceleration, third part is the common acceleration, which is a very simple exercise. Common acceleration of the system is equal to maximum force divided by total mass. F maximum is 36, and this is 9. 4 meter per second square. This is the maximum acceleration of the system. As a third example, M1 10 kilogram, M2 10 kg, M1 is 20 kg, and F is applied on the upper block. mu1 is 0.1, mu2 is 0.2. Is together motion possible or not? So possible check is together motion is possible or not. So to check for the necessary and sufficient conditions, necessary condition is mu2 should be greater than mu1, so 0.2 is greater than 0.1. so first condition is satisfied. Now go for this sufficient condition. So mu2 upon mu1 must be greater than m1 plus m2 divided by m2. This is 0.2 divided by 0.1 should be greater than 10 plus 20 divided by, this is 2 greater than 3. No, this is wrong, this is wrong. Sufficient condition is not satisfied, so together motion is not possible here in this case. Okay, so इस condition में से स्लाइडिंग हो जाएगी m1 m2 के बीच में, और मैक्सिमम फोर्स कितना होना चाहिए? द मैक्सिमम फोर्स शुड बी फॉर स्लाइडिंग, यहाँ पर F2 वर्क करेगा, F मस्ट बी ग्रेटर देन F2, so F must be greater than or at least equal to F2, which is equal to mu2 m2g is 0.2 into 10 into 0.2, so 20 Newton. Okay. Now take another example, which is the last one. This is 30 kilogram and this is also 30 kilogram. And the coefficient of friction mu1 is equal to 0.1 and mu2 is equal to 0.6. First we have to check whether the together motion is possible or not. Check for together motion. First, sufficient condition, necessary condition is mu2 greater than mu1, so 0.6 is greater than 0.1, so necessary condition is satisfied. So go for sufficient condition, which is mu2 upon mu1, which is equal to 0.6 upon 0.1, which is equal to 6. Now m1 plus m2 upon m2, which is 30 plus 30 upon 30, which is equal to 2. So mu2 upon mu1 is greater than m1 plus m2 upon m2. So both the necessary as well as sufficient conditions are satisfied. There is together motion. The together motion possible between the two blocks. And what is the maximum value of force? So F maximum is equal to again m2 upon m1 into G m1 plus m2 into mu2 minus mu1 m2, this is 30, this is also 30, this is 10, this is 30 plus 30 into 0.6 minus 0.1, so 10 into 60 into 0.5, 300 Newton. Okay. So maximum force for together motion is 300 Newton in this case. Together motion is possible, which was testified by necessary and sufficient conditions, and the maximum value of force बिना कोई फ्रिक्शन की डायरेक्शन लगाए डायरेक्ट इस एक्सप्रेशन से जो कि हमने अपने फार्मूलेशन में ड्राइव किया उससे निकल के आ गई, विच इज़ 300 न्यूटन. सो स्टूडेंट्स, होप यू एंजॉयड द वीडियो, और इसी तरीके के और वीडियोस को देखने के लिए, फिजिक्स के कॉन्सेप्ट को डीपली अंडरस्टैंड करने के लिए, कीप वाचिंग, डू लाइक एंड सब्सक्राइब Stargate Educational Research. Have a very nice day and enjoy this formulation. Okay, thank you.